Hey guys, today I want to talk to you about ratio tables. And basically, you know, a table has a variety of information put in it, and these are all going to deal with ratios. So let me give you a quick definition of a ratio table. This will take us 2 pages today, and when you see the title again of Lesson 1-4, Ratio Tables, today's date 11/4/19, you know that would be your second page. So ratio table is a table where all of the columns, have ratios with the same value. Now, in order to have ratios that are different looking but have the same value, that is a special word. That's called equivalent ratios. We've talked about equivalent fractions before. Oops, sorry. There I go writing fractions. Ratios. Equivalent ratios are ratios that simplify to equal the same ratio. So as I simplify, as I reduce, I go back to the same value over and over and over again. So let me give you a quick example of that, and then we'll practice a couple problems. So my mom has this famous punch recipe, and it's really not famous. I mean, everybody loves it, so I guess you could say it's famous in that respect. But what makes this super great is that it's a very simple recipe, and you can have all sorts of variety to it. Now, it's made up of 2 ingredients. That's it. That's what makes it so awesome. 2 ingredients. 1, you can use soda, and 2, we're going to have juice. So I can change up the soda, and I can change up the juice. Now, this is a table. I'm comparing 2 values. And I am going to talk about what if I wanted to make one, it's just for the family. We were going to have dinner. So we're going to get 1 container of soda and 3, let me change my color there, 3 containers of juice. So basically, it could be like 1 cup of soda and 3 cups of juice. So it's a 1-to-3 ratio of what we're drinking, okay? But let's say that a couple of friends came over, so 1 batch was not going to be enough, so we decided to double it. Kind of like with your recipe project, you doubled up, quadrupled, took to 1/3 kind of idea. But we're going to double up the recipe. So if you notice, I went from 1 to 2, and to do that I would multiply by 2. So if I'm going to multiply the 1 by a 2, so I'll just kind of show that right here. I'm going to have to do the same thing here, okay? And that's kind of what we're doing when we're filling out this ratio. So now that I have, for every 1 soda, I get 3 juices. So for every 2 sodas, I end up getting 6 juices. And let's say we had a whole bunch of people show up unannounced. So thankfully, my mom keeps things stocked. So now we have 3 soda portions, and let's see, if we had 3 and then we doubled it, and now we're going from 1 to triple it, so 3 tripled is going to be 9. So what you can see is, I'm just going to write these in a plain color, 1/3 is the first ratio. That's got to be the same as 2/6. Well, if I simplify 2/6, it equals 1/3. So that is the same ratio. And that's got to be the same ratio as 3 to 9. And if I simplified 3/9, I would get 1/3. So if you notice, all 3 of the columns ratios are exactly the same. Okay? Now, what's going to be interesting today, we're going to have to do a couple of different strategies here, but we use ratio tables. Easy for me to say, huh? We use ratio tables to make values larger I added a little extra hump there. Values larger or make them smaller. So for the first set of practices you're going to see, you're going to be basically having 2 columns. You may have 3 columns, but sometimes you don't always have. You can go directly from what you're given to what you want. So it's kind of strange how they'll give you 3 spaces, and there's ways to do it if you want to, and I'll show you that too when we get on the other side. Okay, so let's go to the next page and let's do our 2 examples. So the first one is a patient receives 1 liter of IV fluids every 8 hours. At that rate, how many hours will it take to receive 4 liters of IV fluids? So what we have is a little table. It's a little messy, so I'm going to kind of fix it a little bit. You might want to do the same thing so it really looks like a table. And what you're going to notice is it has the titles of what the numbers represent. So IV fluids in liters on top and time in hours on the bottom. And so that first statement, 1 liter of IV fluids over 8 hours, okay? So it says at this rate, how many hours will it take to receive 4 liters of IV fluids, okay? So what I want to do is figure out, and this is where we get to be a math detective, how do I get from 1 to 4? So I'm only looking at where I have given numbers straight across from each other, not up and down because they make a pair, they make a ratio. So to get from 1 to 4, I would need to multiply by 4. But remember, we're always fair is fair. So if I do one thing to the numerator, I got to do the same thing to the denominator. Think about a ratio that way as a fraction. So 8 times 4 is 32. So my answer to this problem would be, it takes 32 hours, could you imagine, for a patient to receive 4 liters, try that again, upside down, must be tired, of IV fluids. Okay? Now, if I took 4 seconds and I reduced top and bottom by 4, I'd go back to 1/8. So those two are considered equivalent ratios. All right, let's look at the next one. To make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. To find the amount of sugar needed for 4 cups of cranberries, or find the amount of sugar needed for 4 cups of cranberries. So basically somebody has a recipe for, let's say, canning, where they're going to make a lot of this cranberry jam, and then they're going to give it away for presents, or they're going to keep it in stock for themselves. The reality is, if I just wanted, a jar or so for myself, I don't need that many cranberries or that much sugar. So what I'm going to do is figure out how to go from what I know to what I want. So where I'm going to look is here at the cranberries, because I see I have a 16 and then I'm going to a 4. You know what, I'm going to darken in this table as well. For some reason, they came out really pale. I didn't do this in the last one, but I might as well go ahead and do that too. Makes it better. Okay. So I don't know why that guy's so big, but he is. Actually, I'll show you what I've seen in the book that they make you do. They'll put in 3 columns. Now, honestly, I feel you can go directly from 16 to 4, right? Divide by 4, and you can divide 4 evenly into 12. The only time I would use this middle column is if I couldn't get whole numbers when I either divided by the same value, multiplied by the same value. So what I'm going to do is show you how to do it in the intermediate. So let's say, 12 and 16 are both even. What if I divide by 2? Now I know the answer I'm going to get for the 16 is going to be a number that could lead me to 8. Okay, so 12 divided by 2 is 6, 16 divided by 2 is 8. But I don't want to stop there. I want to get all the way to 4. So 8 divided by 2 is 4. 8 divided by 2 is going to give me, 6 divided by 2 is going to give me 3. Now again, I could have popped from one to the next directly. I could have said, oh, if I divide 16 by 4 and I divide 12 by 4, then I can get 16 becomes 4 and 12 divided by 4 is 3. So I get the same exact answer. So my conclusion is it would take 3 cups of sugar to mix with 4 cups of cranberries to make cranberry jam. Okay? All right, so on the next page we're going to talk about what do we actually call it when we're multiplying to get it bigger, dividing to get it smaller. So that's going to be on my second page of my notes, and that's going to be dealing with this notion of scaling. So remember, if you make a scale, you're either going to take something small and scale it larger, or you're going to take something large and scale it smaller. So you've seen that in science classes and in social studies classes. So scaling is simply multiplying or dividing. Two related quantities. That's where your ratio comes from, okay, that vertical, by the same number. So that's what we've been doing already, is scaling, okay? Now, scaling goes 2 directions. Scaling can either be up, or the book says forward, scale up, or forward. I'm going to use the word up, just to let you know. And what that means is we're going to multiply the values in a ratio to reach a target number. So that's, again, something they give us. And therefore, we're going to create what's called an equivalent ratio. Okay? And then, let's talk about scaling back. So to scale back, and we wouldn't say backwards, back is enough, we would divide, or dividing the value in a ratio to reach a target number. And therefore, when you treat both values the same in that ratio, it will create an equivalent ratio. So let's do a couple of examples here. And again, this whole point is we're going to become math detectives. So let's say we are interested in height in 2 different measurements, centimeters versus inches. So we're going to make a little table here. We're going to have 3 columns. And we're going to be given that if you are 25 inches tall, then you are 10 inches tall. Now, that's the shortest human being ever. And then we eventually want to get to figure out what is the height of somebody in inches if they're 105 centimeters. So what I notice is I can't actually get from 25 directly to 105. So I'm going to have to figure out another route to get there. So if I could get 25 to become 5, then I know 5 can go into 105 because 105 ends in 5. So what I'm going to do is divide, which means I'm going to scale back. So I'm going to divide by 5, the top and the bottom. So that's going to give me 5, and 10 divided by 5 is 2. So my first step was to scale back by 5. And then I'm going to scale up or forward from 5 to 105. And if I multiply by 21, that's going to give me from 5 to 105. So if I multiply 2 times 21, I get 42. So my second step was I scale up by 21. Okay? So my conclusion is someone who is 105 centimeters tall, I don't like that comment, is 42 inches tall. Okay? All right, let's try another small one. This one I want to compare two different currencies. Funny enough, they both have the same label, and that's going to be an American dollar versus a Canadian dollar. Now, the values I'm going to have in my table may not reflect accurately what's the value today, but that's okay. So we're told at one point that 50 American dollars was the same as 60 Canadian dollars. My question is, how many Canadian dollars would actually equal 20 American dollars? So again, I can't go from 50 to 20 directly, so I'm going to figure out another way of doing it. And what I notice is both my 50 and my 60 have a 10 in common. So whatever I'm going to scale up or scale back by in particular, it's got to be something that goes into both values in the ratio. Otherwise, it's not going to work. So that's going to give me a 5 for the American dollars and 6 for the Canadian dollars. Now, I can get from 5 to 20 by scaling up. So I'm going to scale up by 4. I'm going to scale up by 4. And that's going to give me 24. So again, step by step, I scale back by 10, and then I scale up by 4, and I get 20 American dollars is the same as 24 Canadian dollars. Okay, got a couple more to practice on the next page. When you're ready, go ahead and switch your screen. I'm going to go ahead and switch now. You can pause if you need to. So, next one talks about cans of corn are on sale at $10 or 10 for $4. Find the cost of 15 cans. So they've already done a table for us, and so what I need to get is from 10 to 15. Unfortunately, I can't because there's not a number that directly goes there. So what I can do, though, is 10 and 4 are both even. So I'm going to scale back by 2, top and bottom. That's going to give me 10 divided by 2 is 5, and 4 divided by 2 is 2. So I'm going to scale back by 2. Now, I can get from 5 to 15 by scaling up by 3. Scale up by 3. So 2 times 3 is 6. So my conclusion is, let's see, 15 cans of corn cost $6. Okay? And there we go again. So last one is interesting because they didn't give us the table, so we're going to have to create that ourselves. Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? So I'm going to do mine is going to be number of hours versus number of lawns. Get that all the way over. And we'll have 3 columns. So again, he took 14 hours to mow 8 lawns, and we want to know how many lawns would he mow in 49 hours. Okay, so always fill in the given, and then I figure out what I need to do. Unfortunately, I can't multiply 14 by anything to get to 79, so let's see what else could we try. Well, we could scale back. 14 and 8 are even, so let's divide them by 2. It's going to give me a 7 on the top and a 4 on the bottom. So again, I scale back, not scale bye-bye, back by 2. Okay, ooh, look what that did for us, little detectives. I can scale up from 7 to 49 by multiplying by 7. So I'm going to do the same thing below. So I'm going to scale up by 7, and 4 times 7 is 28. So my conclusion is Joe can mow 28 lawns in 49 hours. Okay, so this is just a way that we can use these ratio tables to help us figure out mystery answers. All right, good luck with this, guys. Talk to you about it tomorrow. Bye.